Good afternoon, ladies and gentlemen. Welcome to Math 30-2, Chapter 5, Sections 1 and 2, Polynomial Functions, Characteristics of Graphs. Now, the outcomes today, there are three. First, describe orally and in written form the characteristics of a polynomial function by analyzing its graph. 7.2, describe orally and in written form the characteristics of a polynomial function by analyzing its equation. And matching equations in a given set to the corresponding graphs. Now, for those of you who don't remember, polynomial means more than one term, or many. So, y equals 3x plus 1, or y equals x squared minus 7x plus 6, or something like that. Those are polynomials. Now, something you should remember from Math 10. Anyway, now, some other things you have to note. The X-Intercept, where the graph crosses the x-axis or the horizontal. Now, that means when you get a graph like this, the X-Intercept, wherever it crosses the x-axis, remember this is x, this is y, and that leads us to the y-intercept. That's the value where a graph crosses the y-axis, the vertical bit, right there. Okay? So x and y-intercept. Now the domain is all your possible x values for a graph, and your range is all possible y values for a graph. Now these important definitions we're going to talk a lot about, so take a moment to make sure you've got them and you understand them. X-intercept, y-intercept, domain, and range. Okay? If you need to pause the recording, take some notes on the back of your recording machine. Now, what I need you to do is to determine the intercepts, domain, and range of each of these graphs. So this purple one here, x-intercept, y-intercept, domain, and range. And notice I'm abbreviating it because I can't spell. Okay. All right. So x-intercept. Here, I'm doing this with you because it is none. It doesn't cross the x-axis. Notice it goes straight across. It crosses the y-axis, y equals 5, or 0, 5. That's your x coordinate and y coordinate. The domain are your x values. X is all real. And your range, y equals 5. Now I want you to note that. Several important things here. This particular purple line goes on forever. Notice the arrows. That means it goes on. You have to look at the graph carefully. Sometimes the arrows are really small. But if they're dots, it means it stops at that point, or starts. But this is what I need you to be able to do. Where does this cross the x-axis? It doesn't. Now, that leads down to these two red ones. X-intercept, y-intercept, domain, and range. Now, I'm going to do this second one with you because it's a little sneaky. The x-intercept, well, it's all, which is weird, because if it goes left and right, it either misses the x-axis or it hits all of them. The y-intercept is y equals 0, or 0 times 0. X value, my y value again. My domain, x is all real. And my range, y equals 0. Okay? Now remember, this YER thing means x is any real number. Any number you can think of. 5, 11, 3, a million, 7, minus a half. If you can think of a number and put it in your calculator, the graph will go. Right? Now, I'm going to pause the recording, and I want you to do this third graph here. X-intercept, y-intercept, domain, and range. Alright? So pause the recording and we'll come back with your answers. Okay, for this one, factor of x equals 4. Remember, that's a fancy way of saying y, the equation is y is 4. The x-intercept is none. The y-intercept is y is 4, or the coordinates are 0, 4. Domain, x is all real, range y is 4. Sort of see a pattern forming here? Good. Now, these are the tough ones. What you're normally going to see are like this bluey purple one, and I'm going to call this the purple one because it kind of looks purpley to me. I don't know what it looks like in your photocopy. And the blue one. So for this purple one, X-intercept, Y-intercept, mean, range. The X-intercept crosses at x equals 2, or 2, 0 coordinates. The Y-intercept is down here, y equals minus 4. Notice in this particular graph, I typed it out for you, Frank. I forgot to edit it out. Minus 4. The domain, x is all real. And notice my y values. This graph keeps on going down and up. Means this goes over this way and it goes up. So that's how come I get my domain is all real, because as it goes up, it goes over, and as it goes down, it goes across. But as it goes across, it also goes up, goes down, so y is all real. So you should see a pattern forming here. Alright? Now, X-intercept, Y-intercept, domain, and range. Why don't you guys try this one, the blue one? So, actually, I'm going to pause recording, you guys do it. Okay. When I did it, X-intercept, x is 1, or 1, 0, Y-intercept, y is 1, or 0, 1. Domains, x is all real, range, y is all real. So any value of x I can think of, I can plug it in, and it will work. And if I look long enough in my table of values, I can find any value of y, as long as it's a real number. Okay? Now, tricks? Of course. Here's one here. Baby's length in inches. And the x-axis, and the growth period, I'm assuming the y-axis is, yes, would have to be inches. For some reason, it got cut off. Lovely. Anyway. X-intercept, Y-intercept, domain, and range. Now, X-intercept, there's none. The Y-intercept, I think is 20 inches, or 20. It is 20 inches long when it's born. Right? Now, why is this tricky? Notice it ends in a dot. At 16, it stops. So we're only measuring 16 weeks, or 16 months. Probably weeks. So x is less than or equal to 16. Now, it's not immediately obvious, but what happens when a baby's born? There's a start. So, this is time. So we're starting at 0 weeks. So our domain is 0 to 16. Okay? There is limits here, in reality. And the range. What is the smallest length of the baby? 20 inches. What's the biggest length of the baby? I'd say it's 24. I agree, not the best graph. I should go back and edit it, but... Okay. So, graphs stop and start. That's one big thing you've got to notice, in reality. And something else is they're not always a straight line. Ooh. Notice this curved graph here, parabola. X-intercept, Y-intercept, domain, range. Now, there happens to be two of them, and note, there's a next to you, and I label them. X-intercept is 3, 0, and 4, 0. Now, I didn't label the Y-intercept, but that looks suspiciously like minus 12. Right? Now, what else is confusing about this? Well, the domain. As this graph goes up, it goes out. So, x eventually will hit every real number. What about my range? Well, here's the important point. There's a minimum. Y is greater than or equal to minus 12.25. Give you the 4. I'll give you the coordinates of the minimum. Emphasizing that. Okay? So, for curvy graphs like this, quadratics, there's a minimum or a maximum value. Now, I'm going to be quiet, and I want you guys to do the x and y intercepts, if they have any remaining range of the following graphs. Alright, quickly looking at these, for this graph, I just realized I should color code this when I'm coloring red. Yet there's no x-intercept. The y-intercept looks to be about 5 or 0, 5 for the coordinates. The name, x is all real, range, y is greater than or equal to 3. Now down here, we have 2 separate graphs. I apologize, I should have color coded them earlier, but the upper one I'm calling green. No x-intercept, y-intercept is 0, 1, domain x is all real, range y is greater than or equal to 1. The purple one is a little sneaky, because you look at your x-intercepts, and you're guesstimating. So, ish. Minus 0.3 and 2.3-ish. Maybe 2.2 and minus 0.4. Sure, something like that. Estimate. Now on a test, I would give you a better graph than that. It would go exactly through 2 or exactly through 3. That was shit. But, welcome to reality. Now, the y-intercept, y is 1. The domain, x is all real, and note the range, y is less than 3, because 3 is the biggest value. Alright? So it's going down, so y is less than or equal to 3. Now this is it for the first part. Review this if you have any questions, otherwise go on and we'll start looking at the next type of graphs. Right? Good luck.